Hi, everybody. Welcome back to the Shiko SAT review series. And this is the second video under this unit of the linear equations, and it's interpreted the slope and the intercept of the linear equation. So from the worksheets, we total have 24 problems. And for the first video, we covered the first 12 problems. So in here, this video, we're going to take a look at the remaining 12 problems about what type of the problems SAT, they will give regarding to the slope and the intercept of the linear equation. Okay, so now I'm going to go to the worksheets, the one we stopped last time, and let's continue to work on that. Okay, so let's take a look at the worksheets, okay? So we started this last time, and now let's start here, and let me find my pencil. Okay, so here, so let's start here. And before we start, I'd like to do a very brief review, and because we already covered in the previous video, so I'm not going to spend too much time. Just before we start doing the problems, I'd like to do a very brief review just in case you don't remember. So we say the one of the linear equation form, the most important one is mx plus b, right? So what is the m's here? I think everybody know the m, this is the slope, right? So that's the slope form. And what is the b here? B is the y-intercept. And also from the previous video, I mentioned if people ask you what is the slope, a lot of students will say, hey, it's right over wrong, or it's y2 minus y1 over x2 minus x1. But most of the SAT problems related to the slope and intercept is more like word problems here. So instead of remember the right over wrong, so the slope is here, right? So like I think we talked about the last time. So the slopes here is the rate of the changes here. That means every time when x increase 1 unit, depending on what is the x unit, that's why I need to read from the problems. Now, how much y change? If slope is positive, then that means x increase, y increase. If slope is negative, that means x increase, y decrease, right? Okay, so the next thing is we say, hey, this one's here, this is very important numbers also. So this is the number we call this the y-intercept. So we know how to get the y-intercept mathematically, right? So you set x equal to 0, you can find the y-intercept. But in the application type of the problem, the y-intercept typical is, in your problem, they will say it's kind of like it's the initial values here. Okay, so that means at the beginning, like we said, if you find the cost, the B could be the cost. Like the example we did in the previous video, we say if you have a food truck and you want to sell the tacos, so the B could be the food truck cost. That means the rent you need to pay every month. Doesn't matter you sell hundreds tacos or 0 tacos, right? So that's what we call it, initial cost or initial value. Okay, so now let's a brief review. If you kind of don't remember very well, go back to the first video at the beginning before we do the problems. I did give a kind of the detailed explanation to that. Okay, so now let's take a look at number 13 here, right? Okay, so the number 13 here, let's say the equation above the model, the total cost y in dollars. Let a company charge a customer to rent a truck for 1 day and drive the truck X mile. The total cost consists of the flat fee, all right? So see here, you see the keyword here, the flat fee, all right? And plus a charge, right? Plus a charge per miles driven here, all right? So that means, so if you take a look, so the flat fees here is like, so the flat fees here is kind of like the fixed, we call it the initial values. It doesn't matter, right? So in here, if you rewrite this equation to y equal to 1.5x plus 1999 here, all right? So if you rearrange these two, then we know this is the slope, correct? So this is the slope. I'm sorry, this is the intercept, right? So this is y-intercept. So in this problem, they say when this equation graphed here, what does the y-intercept of this graph mean? That means that it's 19.99. That's what that means, right? So it's the initial value, a fixed cost. So what is the answers here? It's the flat fee, right? So it's the fixed cost here. Doesn't matter you drive 0 mile or you drive 100 miles, right? So you're going to pay this flat cost. That's what we call it, the intercept here. Okay, so let's take a look. The next one is here. The seller want to purchase a ticket from a vendor to watch a tennis match. The vendor charged a one-time service fee. So, whoa, okay, so you highlight a one-time service fee. It's kind of like the fixed cost, right? And processing the purchase of the ticket. Then the equation is 50M plus 12 represent total amount in dollars the seller will pay for the N tickets here, right? So what does the 12 mean in this equations here? So we know the one-time service fees, right? So 12 is here. So 12 really is what? 12 is the y-intercept, right? So 12 is the y-intercept. Like we said, y-intercept. What is the y-intercept? Is the initial fee, right? So, or the fixed cost or flat fee. So in here, this is what we call this the service fee. It has nothing to do with how many tickets. You buy 20 tickets, you still need to pay $12. You pay $40 tickets, you pay $12. So what is the 12 mean? So it's the what? It's the amount of the service fees, right? So what is the 15 mean? So if they ask you what is the 15 mean? So the 15, that means each ticket, right? So each ticket is $15, all right? Okay, now let's take a look at number 15 here. The number 15, they said at a restaurant, N cups of the tea are made by adding the tea bags to the hot waters here. So if T is equal to N plus 2, okay? So how many additional tea bags are needed to make each additional cup of tea here, okay? So N is the cup of tea, right? So the N is here, let's highlight here. Okay, so N is the cup of the teas here. And then what is this numbers here? So the 2 is we call it is the y-intercept, right? So in here, the 2, that means it doesn't matter how many teas you make, right? So you need to have an initial 2 bag. Then, you know, like each cup, you put one extra bag there, right? So because this is 1 times n's, right? So that's why when they say additional cup, right? So the how many tea bags are needed for the additional cup of the tea. So that means that whenever the n increase 1, how much the tea increase 1, right? So that means you will need so how many, you know, the tea bags need? So 1 extra tea bag if you want to increase 1 extra cups here. All right. Okay, so now let's take a look at number 16 here. Okay, so number 16 here, right? So this one's here, they say Alan drive an average of 100 miles each week. his car travel on average, right? On average is 25 miles per gallon of the, per gallon of the gas. Alan would like to reduce his weekly expense on gasoline by $5. Assume gasoline costs $4. Okay, so let's highlight all these informations, right? The gasoline is $4, and he want to reduce by $5 here. So which equation Alan used to determine how many fewer miles you need to drive here? Okay, so here we also have these ones here, right? So those are the 100 miles, and so each gallon can travel 25 miles, and he traveled 100 miles. So let's take a look at what is the monthly, weekly, sorry, so this is weekly, right? So let's take a look. What is the weekly cost? Right, because the 25 miles, right? So in the 100s, how many 25 miles I have here? I have a 4. That means I need to use the 4 gallons, right? So this is 4 gallons. And then each gallon is how much? It's $4. So the total cost here will be $4 times 4. So the total cost is $16. All right. So the total cost is $16, right? But now the Alan want to reduce by 5. That means how much the cost right now he wants here reduced by $5. That means this week he only want to spend $11 on gas. Now how much, how many fuel, the average mile he need to drive. Okay, so here this is how we set up, right? So we say 100, right? So 100 miles, he's going to spend $16. Now, here is how many miles, right? So it's X if he only want to spend $11, correct? Okay. Okay, so now you do what here? We do cross product, right? So it's 16x is equal, so you do a cross product. So 16x is equal to 100 times what? 100 times 11, right? So 100 times 11, so now the x here will just be 100 times 11 over 16, so correct? Okay, now here, this one is really just wording problems here. So they ask, they say, how many few miles he should drive, each week here, right? Okay, so now this is how many miles he will drive for 1 week. We said the how many fuel miles, right? So the fuel miles will say here, they want to use the M. Okay, so the fuel miles here will just be, originally Alan driving 100 miles, correct? Okay, so now he's going to drive 100 times 11 over 16, right? Okay, so now in here you can say, okay, I'm a factor the hundreds out. So this is 1 over 11 over 16. So what is the 11 over 16 here? Okay, so let me move up here. So 11. Okay, so 11 over 6, so this will be 100 times what? So 1 minus 11 over 16, so it's become 5 over 16 here. Okay, okay, so here, now I say 5 over 16, right? So now I can do a little bit of to simplify here. I divide it by 4. So I divided by 4, so this is 25, right? So it's 25 times 5 equal to n, right? So here, I have the formula here, so I have n is equal to 25 times 5, right? So it's 25 times 5 over 4 here. Okay, so now you look at this one is a little tricky, all right? So I think that this is maybe it's the hardest one in this, for all the other problems here. So now you look at the answer, you say, doesn't look like I have the ones here, all the answers here, right? So they have something in front of it. So what I need to do? Well, let's see here. So I say, okay, I observe the relations here. So it seems I have a, I never see like this two, this one have a 95, 95. I never see anything have a 95 here. So I know these two cannot be the answers here, right? So I do have a 5 here, all right, on the right-hand side. So what I need to do is here, remember switch the variable in our previous video. So how do I switch here? So this is 4 times 25, right? So here, this is 4 times 25. So now here is a boom, 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 cancel, right? I have a 5 left. So that's why I have a 4 of 25m is equal to 5. Wow, so which one is the 4 of 25m equal to 5? Haha, I find it. It's a D here. All right. Like I said, this one here is, I think it's the hardest one, in the whole package here. And because the wording is kind of like the very tedious wording, and then it's very tricky. What they try to find is fewer the average. And then the answer choices here. So you just need to see after you solve this, and then here's your answer choice. And then you say, I never see 95 here. So A and C you can cross out. Now you see, okay, by right hand side, I do have a 5 here, right? So that's how do you simplify that and convert that. All right. Okay, so now let's take a look at 17 here, right? Okay, so the number 17, they tell you the downtown business association in a certain city plans to increase its membership total of N business per year. Oh, I see that, right? So N business per year. This per is very important. That's the rate of the changes, right? And also, then they say there will be business, right? There will be business in the DBA at the beginning of the year. Whoa, this one is good. I find my 2 key items. So they say, what is the total number of the business? Why is the DBA plans to have a member X years from now? So I know this is a very standard, like MX plus B type of the problems, right? So I know from here, M is every year, how much, they want to do is N's, right? It's NX. Then plus, what is the initial value? Is B's here, right? Okay, so that's why I say after you find those 2 keywords, then the problem becomes pretty easy. So what is the answer? Answer is A here. All right, okay, next one. Okay, so next one's here, they ask you the number of the states that joined the United States between 1776 is twice. Okay, so highlight. Okay, so highlight the word is twice the number of the state joined between 1850 and 19. If 30 states joined the United States in the 1776 and between 1776 and 1849, and the X is the states joined between, right? So then which of the following question is true here, right? So X here is the number of the state joined to United States of America between the 1850 and the 1900s, right? So the state joined earlier from the 1776 to 1849 is what is twice the number. right? So that means I know the 2x is the number joined between. So this is the number of the state joined between 1776 and 1849, right? So the 2x and how many layer? It's 30, right? Okay, so that is our answer. So it's 2x equal to 30. You see that? So it's pretty straightforward. You just need to be careful when you read the problems here. Okay. Okay, let's take a look at C's here. Let's see if we can find number 19 is here. Let's see if we can find any key information. Okay, so they said the average number of students per classroom at the Central High School from 2000 to 2010 can be modeled by this equation. Oh, perfect. This is the equation we like. This is the, we call it slope. It's here. And this is the intercept, right? Okay, so they give us the equation. Okay, so we highlighted, we know which one is slope, which one is the intercept, where x represented the number of the year since 2000 and y represented the average number of the student per classrooms here, all right? So the number of the student per classroom, which of the following is the best describe the meaning of the number 0.56? All right, okay, so now let's take a look here. So the 0.56 is what? So it's the number of the what? It's the number of the student going to increase the per year. So that means when x increase, right? So y going to increase. All right. So let's see what is the, which one is the, here's, is the total number of the student at the school? No, it's not the total, it's the rate of change. And so it's the average number of the student per classroom in 2000. Oh no, it's not, because y is the average number of the students, right? Okay, so let's take a look. The C here, the estimate increase in the average number of the student per class each year. Oh yeah, because these ones here, this is a positive slope, right? So this is positive, so when the year increase, then the y increase. So it will be C here. Let's take a look at why the D is not right. They said the estimated differences between the average number of the students per class. No, it's not the differences, right? So this is not right. So we did not say it's differences. So this is a very standard slope and intercept. So 0.56 is the every time when x increase 1 unit, how much y increase, right? Because it's positive, so we say it's y increase. Okay, very good, super good. Okay, let's continue here. Okay, number 20 here. So the pediatricians use the model above to estimate the height of a boy in inches in terms of boys' ages here. Wow, this is a good one here. Also, we have the slope here, we have the intercept here, right? So then the A is what? A is the ages here in, A is the ages here in years, so the units is years, right? Okay, so, and the 3 is increase, is a positive, right? So let's say based on this model, what is the estimated increase in inches of a boy's height each year? So what we are looking for here? We are, because they are asking, so what is the estimated increase in inch each year, right, per year? So it's rate of change. So what are we looking for? We're looking for the slope, right? So it's a 3 here. Okay, so this is easy here, okay? Okay, number 21 here. The number 21 here, it tell you the equation above show the temperature of the Fahrenheit and the Celsius, their relations here. Based on the equation, which of the following is true? Okay, so here, okay, so now let's try to, so this is C, if you want to be a little bit, so this is 59F minus You just use the distributive properties, right? So it's 160, right? So 5 times 32 is 160. Okay, so if you write this way, so this is a standard form, right? So this is my slope. And what is here? This is my y-intercept. Okay, so now let's say here. So in here, they ask you, they say, hey, a temperature increase 1 degree is in the Fahrenheit. Okay, so it's, that means in here, you know, that your X number is Fahrenheit, right? So when X increase 1 unit, so what does the slope mean? That means Celsius. That's your Celsius right now. This is your Y, right? So this is your X here. That means when Fahrenheit increase 1 degree, so what happened to your Celsius? Your Celsius increase 5/9 here, correct? Okay, so this is okay. I like this one. Okay, all right, so now the next ones here, they say the temperature increases 1 Celsius is equivalent to temperature increase 1.8 Fahrenheit. Okay, so let's see here. So the Celsius is, this is 5/9 to the F minus 32, right? So now I'm going to change the Celsius become my axis here. So I'm going to times what? 9/5. So here I'm times 9/5. So I'll be able to cancel, right? So here, boom, 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 boom. So I will have, so this will be F minus 32 is equal to the 9/5 to the Celsius. So if you plus 32 plus 32 here, so you will find that this is F is equal to the 9/5 Celsius plus 32. So if you look back here, wow, this is good. This is the my standard form again. So this is the what? This is my slope, and this is what? This is my y-intercept. So for this problem, so the Celsius become X and Fahrenheit become Y. So let's read here, right? So let's read here. Let's say a temperature increase 1 degree in Celsius. Oh yeah, so increase X. So how much Y increase? It should be 9/5, right? So the 9/5, in here, the 9/5 is equal to what? Equal to 1.8, right? So let's say the Fahrenheit going to increase 1.8. Is that right? Oh yes, this is okay. Okay. Okay, so let's take a look at 3. They said a temperature increase 5/9 degrees in the Fahrenheit, okay, is equivalent to temperature increase 1 degrees in the Celsius. Okay, so no, that's not true, because when the, you know, when the Celsius increase 1 degree, Fahrenheit need to increase what? 9/5. So it's not a 5/9. So this is not true. So this is 9/5. So what is the answer? Answer will be D, right? So will be both 1 and 2 is the same here. Okay, so now let's take a look at the other ones here. Okay, so I think this is our last problem, has 2 parts. Okay, so this is a supply and the demand function. So let's say the quantity of the product supplied and the quantity of the product demanded in an economic market are function of the price. All right. So the function above an estimated supply and the demand function for the certain product. The function SP give the quantity of the product supply, the market, when the price is P, and the function DP give the quantity of the demanded by the market when the price is the P. Okay. Okay, so let's say, how will the quantity of the product supplied to the market change if the price of the product is increased by $10, okay? So we are looking the supplies here. And this is kind of looks very good equations, right? So this is kind of like a looks good equation. So this one is like my standard. So if I color that up, so you will see here, right? So this one's here, you can treat this one as y values, right? So this is the y, and the p is what? Is your x values here, correct? Okay, so they are asking you, you know, the quantity of the supplied here. So they say, how about if the product, right, increase by $10? So here is they try to trick you. Increase by $10 here, right? So what is the 1/2 mean? So the 1/2 here is the slope, right? That means the supply going to increase 1/2, right? So y increase 1/2 when x increase $1, right? So now they said how much is the supply if the quantity, you know, if the price increase by what? The increase by $10, right? So it will be 10 times 1/2. So it's 5 here. Okay, so let's take a look here. Okay, so why the answers? Okay, so in here, the A is not. Why? Because they say decrease. And look here, my slope here is positive, right? So positive is increasing, so A is not. And then the part B is here, the quantity of supplies increase 5 units. Yes, this is the answer. Okay, so then they say the quantity of the supply will increase by 10 units. No, it's not, right? Because each unit, each dollar only increase 1/2. So only the five units here. So the 50 units is not right. Okay, so now let's do the last ones here. They say at what price will the quantity of the product supplied to the market equal to the quantity of the product demanded by the market? So you see here, right? So that means this is the y also, right? So now let's say the problem said here, hey, what is the supply equal to the demand? Correct? Okay, so that's what basically they say, hey, if supply equal to demand, then what is the price? So you will say, okay, supply is 1/2 P plus 40 is equal to 220 minus P here. So they want you to find, so they want you to find the price. So basically you just solve the equations here. So remember we say, okay, so this is how we solve the equations here. So 1/2 P plus 1 P is how many P? 3/2 P plus 40 is equal to 220. So minus 40. So this is 3/2 P equal to 180, right? So the equal to 180, then I can, in here, get rid of this parenthesis, get these fractions, 2/3, so times 2/3, right? So when you times 2/3, 2 cancels, 3 cancels, right? Okay, so now you will have P is equal to, so it's 360 divided by 3. So this one is 360 divided by 3. So how many you have? It's 120 here, right? So what is the answer for 120? It's B. Okay. All right, that's it. This is a long package and got many problems, but that's why, I gathered these 24 problems. That's why you see every year the SAT exam going to have 1 or 2 those type of the word problems, and they just want you to fully understand what is the meaning of the slope, right? So it's the rate of the change. That means whenever x change 1 unit, how much y will change. Then the intercept, remember, typical is like the initial value, the fixed cost, the flat fee, those things. All right, so that's it for this ones here. And then make sure you understand that, because this type of problems are going to happen. All right, so every SDC exam, they're going to have a similar type of the problems here. So they most likely will be the word problem. So you just need to read the problem carefully and then maybe highlight the key things. Like every time I do the problem, I highlight and say, oh, I see this one. This is tell me it's the initial value. So I highlight. Then I'll say yellow. So this is intercept. Then they said change per year, per week. Now I highlight that. That means the rate of the change. That's my slope. All right. Okay. So good luck. So I'm going to stop here, and then looking forward to talk to you for our next videos. Here we're going to take a look at how do we find the linear equations here. All right, so now that's it, and you have a good day, and I'll talk to you soon for our next topics here. Okay, bye.